Our observations is that it requires some type of a force, represented by this figure pushing on the box, to have something move. That seems to be a bit counter to what Newton was telling us in the last video, is that an object will continue moving even without an unbalanced force. This seems to fit in more with our normal observation. If I push a little harder, I speed up. If I don't push as hard, I start to slow down. And a little figure can only run so fast. Watch what happens as soon as he runs out of juice here. He falls down. And when we don't have a normal force applied to this, we see here the box is slowed down, more in keeping what we see in the world around us. And we're continuing to slow down, and finally, when we have no net force on here, our object stops. We'll see if we can end up changing the labels all on this and find out what exactly is happening. Now I'm going to run the simulation with the forces listed, sum of force, which we typically refer to as the net force, and their values as well. We'll bring our figure in and start pushing on the box again. You can see that we have a frictional force and a normal force. The applied force here is the force applied due to our normal force. We'll call that normal force. I continue to push a little bit harder. I push harder. I push harder. Now you can see that the object is not changing its motion. Okay, it keeps on doing what it keeps on doing because the normal force applied is equaling the frictional force. Let's push a little bit harder, harder. Okay, hey, so now we finally have a net force to the right, and the object will start speeding up to the right. Push a little harder. I can see that I start my motion, but not only is it moving, it's moving faster and faster and faster. Okay. Hey, what if I back off just a little bit? Okay. Okay. Hey, so now the normal force I'm applying, 250 newtons, exactly matches the frictional force, 250 newtons. Here we see an example of Newton's first law. An object in motion remains in motion unless acted on by an unbalanced force. Right here we can see we have no unbalanced forces. The normal force applied exactly matches and balances the frictional force. Take a look at the speed. The speed stays constant. We'll have our figure push again a little bit harder. We'll see that what happens. We have unbalanced forces, and we can see that the speed does not remain constant. Okay, I have a net force in the direction it's going, so it speeds up. There's going to be a point at which our figure can't go any faster, will fall down. So long. Okay, now the normal force no longer appears. Okay, we have a force that is in the opposite direction to our motion. What do we see? Our speed slows down. Our net force, okay, opposes motion. It slows down, our object's still changing until we reach 0. Again, we can see that the sum of forces equals 0. There's no normal force, and there's no frictional force at this point. Our object's motion does not change. This simulation only talked about forces in the horizontal direction. Of course, we also have gravitational forces down and normal forces up. In this case, because we were having no change of motion in the vertical direction, those forces were balanced.